Hey grade 7, welcome to another edition of Mr. V Teaches Math. And as I mentioned last night, what we're going to be doing today is looking at 2.4 in our textbook, which happens to be on prime factors. So our goals then are to identify prime factors of a number, and then to use factor trees, and I'm going to add in repeated division to write prime factorization of a number. So factor trees and repeated division, I don't know if they're new for you. If they are, the way a factor tree works is we start with the number that we're trying to factor up at the top, and then we have these two little lines that come down, and I need to think of two numbers that multiply together, in this case to 48. So I'll just pick two that I know. I know that 6 times 8 equals 48. Now, I look at these two numbers and I say, well, 6 and 8, neither of them are prime numbers. Our ultimate goal is to get from row to row so that we have nothing but prime numbers at the very bottom. Okay, so I know that 2 times 3 equals 6, and I know that 2 times 4 equals 8. And then I have to put a little multiplication symbol between the two, because basically, as I said, each row has to equal 48. So 2 times 3 is 6, times 2 is 12, times 4 is 48. Now, I'm still not done, because 4 is not a prime number, right? I know that 4 can get broken down into 2 times 2. I need to keep carrying each of these down, so the 2 and the 3 and the other 2, to show them as product of prime numbers. This is when, so we have 2 times 3 is 6, times 2 is 12, times 2 is 24, times 2 is 48. So this is the prime factorization of 48. This shows that 48 can be made by multiplying these prime numbers together. So that's using a factor tree to figure that stuff out. There are lots of different ways that you can show a factor tree to get down to the prime factorization. 6 times 8 is one way. You could have done, 2 times 24, or you could have done 4 times 12, or a couple other options that you could have used as well. It's really up to you. Now, to use repeated multiplication, what we're going to do is just kind of stack division on top of each other. Now, maybe that sounds a little weird, but try to follow me along on this one. So, I'm going to divide 2 into 48. I know that 48 is an even number, so based on our divisibility rule, I know that 2 will be a factor of it. And I know that 2 goes into 48 24 times. So I'm going to start stacking. So I'm going to divide, again, 4 is an even number, so I'm going to divide 2 into 24. And I know that 2 goes into 24 12 times. Stack another division on top. Again, 12 is an even number. I know 2 goes into 12 6 times. 6 is still not a prime number, so I'm going to keep dividing. I'm going to divide another 2 in there. And I know that 2 goes into 6 3 times. Now, 3 is a prime number. So see what I'm doing? I'm just stacking one on top of the other until my last number that I get up here is a prime number. So the way that I write this then, and this is maybe one of the ways where this repeated division takes a little bit longer than factor trees, maybe not, is that I really think it's important to write out the prime factor, or the product of primes at the very bottom, just so you don't forget that we're still trying to show a number as a product of prime numbers. And so what astute viewers will know is I have this repeated multiplication here and say, well, I don't need to show repeated multiplication the long way. What I can do is I can write it as an exponent. So 2 is my base, and then there are 4 of them. So, it's 2 to the power of 4 times 3. And that would be my prime factorization of 48. So those are two examples. That's what you'll be working on. So have a great night, and talk to you guys tomorrow.